Hi everyone, welcome to the session on design patterns. The topic under discussion is design principles of design patterns. The language used to analyze design patterns is C# with .NET Framework. The prerequisites for this subject are agile methodologies, UML notations and diagrams, C# language. Design patterns consist of two major areas: design principles, design patterns. There are 5 design principles called as solid principles. Then in the design patterns, we studied GOF, which is well known as Gang of 4 23 patterns, with 3 other patterns. We restrict ourselves to design patterns and their implementation for this session, and probably in the further session, we will discuss on design principles and the other patterns. So now we will start with the introduction to design principles. What is a software design principle? Software design principles represent a set of guidelines that help us avoid having a bad design. The design principles are associated to Robert Martin, who gathered them in Agile Software Development, Principles, Patterns, and Practices. According to Robert Martin, there are 3 important characteristics of a bad design that should be avoided. The first one being rigidity, which means that it is hard to change because every change affects too many other parts of the system. The second one being fragility, which means that when you make a change, unexpected parts of the systems break. The third and last one being immobility, which means that it is hard to reuse any application because it cannot be disentangled from the current application. How many types of design principles have been identified? There are 5 design principles which are well known as solid principles. They are S, which stands for SRP, which means Single Responsibility Principle. O stands for OCP, which means Open Closed Principle. L stands for LSP, means Liskov Substitution Principle. I stands for ISP, which means Interface Segregation Principle. D stands for DIP, which means Dependency Injection or Inversion Principle. We will begin with the first principle, SRP. This is the single responsibility principle. The definition of this principle goes as: every module or class should have responsibility over a single part of the functionality provided by the software, and that responsibility should be entirely encapsulated by the class. Actually speaking, it means that each class should have one responsibility or method. This makes the class focus on single concern so that the class is more robust. As an example, consider a fisherman. His job is to just fish, not to cook or serve fish. Consider a class implementing this example. It would look like this. Here, if we see that there are 2 classes, fisherman and program. The purpose of the class fisherman is to implement a method called as job, and the purpose of the class program is to implement the main method. As said in the definition, we have provided only one responsibility to each of the class. Now let us start with the second principle, OCP. The definition of the open-closed principle is given by 2 programmers, and they are: the first one, the Mayer definition says the software entities should be open for extension, closed for modification. The Martin's definition says open for extension means that the behavior of the module can be extended, that we can make the module behave in new and different ways as the requirements of the application change or to meet the needs of new application. The second one, closed for modification, means the source code of such a module is inviolate. No one is allowed to make source code changes to it. In short, we should be able to make modifications to the code, but we should not change the entire code. Let us consider the same example of fisherman. Consider him to catch multiple breeds of fish, that is legal, but you should not consider him to catch a turtle which overloads his functionality and thus violates OCP. The same can be seen here. Here we consider 2 types of fishes. The first one, angelfish, the second one, catfish. To implement this, we have 4 classes. The first one, the abstract class fisherman, who provides the abstract method job. The second one, the class angel fisherman, who overrides the job of abstract class. The third one, the class cat fisherman, who overrides job of the abstract class. The fourth one, the class program, which implements main method and is also sealed. Thus, the same fisherman class has been extended to multiple varieties of fish classes, but we have stopped the code from getting modified by using the sealed keyword in the program. Once we finish executing this program, we'll see something like this. The first line says that my job is fishing angelfish, and the second line says my job is to fish catfish. Now let's move on to the third principle, LSP. The definition of Liskov substitution principle says if S is a subtype of T, then the objects of type T may be replaced with the objects of type S without altering any of the desirable properties of T. In LSP, we have two categories of rules, the contract rules and variant rules. There are three contract rules, and they are: no precondition mentioned in the type S can be strengthened in the subtype T. No postcondition mentioned in the type S can be weakened in subtype T. The data invariants have to be maintained in both type and subtype. There are three variant rules, and they are: the first one, the return type of the methods can covary. The arguments of the methods can contravary. The third one, no new exception can be raised in the subtype. To implement the LSP code, we will alter the same fisherman class as shown here. Here, we have an addition function in the class fisherman which records the age of the fisherman. The age of the fisherman is set to 21, and any input given to the age other than this will give the error, and the same is handled as exceptions. This shows us how not to strengthen the precondition. The fourth principle is ISP. The definition goes as said. No client should be forced to depend on methods it does not use. In short, it means that each interface should be designed in such a way that it can handle only one responsibility. This can be realized through the code shown here. Here we have an interface fish, and the class fisherman extends this interface, and as we see that there is only one method given in the interface. Once we execute this program, the output what we see is this: my job is to fish. The fifth and last principle is DIP. The definition of dependency injection or inversion principle says that it is a technique whereby one object supplies the dependency of another object. The meaning of this is we have to try not extending the interface or classes, rather create objects of them and invert the dependency. The same is shown in the code which is present here. Here, the interface fish is extended directly to the fisherman class, but the class client uses the method of the interface through a private object created in the class, thus inverting and injecting the dependencies. Thus, we finished the description of all solid principles. Thank you for watching the session.